All right, here we go. Online office hours for Thursday. I did tell my students that if they came in tonight and they told me who they were in the chat and they interacted, then I would push 5 points towards the quiz category in the face-to-face class that we've got, the stats class. So we're going to talk about a few items tonight. I'll wait for folks to come on. It is just barely after 7 o'clock. I typically run my stream when nobody's here for about 20 minutes. If somebody will show up, I'll usually run it for 45. Just depends. Hey, Artemisia. Good to see you. I'm waving at the picture like you can see it. There we go. Thanks for showing. So we've got our first student, and I will put that in my grade book. And students need, just remember from class, I put these points in my separate grade book, and I don't account for them until the very end. So it comes out in the final grade. So what's in the grade book will always remain the same, but I keep your grades, and at any time I can share those with you. No, good question. No vocab quiz next week, and I will put out some my stat lab problems for you guys this week to practice. Of course, the extension will be passed next week to give you time to master it and have questions. So very good question on the vocab. No vocab next week. So I've got one student in here for 5 points. Certainly we are on the web. Lots of folks could show up. If you were a student in my class, just show up. If I know who you are from previous ones, I might recognize you. If not, just put your initials in there if you have a name on there that's different from your name in class. Okay, so as always, like the professional streamer that I am, I always start off my stream and talk about what I'm streaming with, just so if people are curious, if they want to get started and do it. It's not a difficult thing to do, it just takes time. I have an iMac computer 2015, older computer, doesn't take any updates anymore, just for info. I run Ecamm on here, which is like an overlay like OBS would be for those who are gamers and go through OBS. But Ecamm is kind of drag and drop. So I certainly have to work all my moving parts in here and everything together and try to align it. But I can very easily make this exactly what I want it to look like. Excuse me. So I stream from my iPad on Doceri. So what you see on this background where it says probability continue, that's Doceri from my iPad. And I write up here as we go. Now I'm going to, just for my students who may not ever be able to read my handwriting well, I'm going to start typing these up in Doceri, so at least I've got the problem sets and I don't have to read from my notes, put them on here, or just write them up here. So I'm going to try to extend to that. And at any time I can bring folks in. I don't know that tonight necessarily has to be that night, but if we have a very intense hypothesis test type of discussion or one centered around our project, which I'll get back to, then I can bring you in on this screen as guest 1, guest 2, or however many we need, and we can talk through things instead of having to go through the chat. The chat is sometimes limiting because you cannot put the Greek symbol mu in there without some work. I'm sure there's a way to do it. But just the regular Joe Schmo, like most of us are, that shows up for YouTube or Twitch, cannot just put mu up there or sigma squared or whatever we're working with. But it is very easy to walk through here and talk through it. All right. Oh, shoot. Sorry, I went back too far. I got my Stream Deck. I normally just push the buttons, but today I just seem to be overwhelmed with stuff on my desk. So let's talk for a second. I've got several items up here. I don't necessarily want to talk about these. I want to move on to the next slide. This is an older slide. Let's talk about mutually exclusive events for just a second, because the gist of tonight's discussion is going to be an extension from class of what we're doing in probability. And I want to talk about addition rule in a little bit more, with a little bit more, what do you call it? I want to do some problems, basically. And I want to talk through those problems and use the addition rule to work through those as we're talking about OR situations. Before we get into it, just a recap of mutually exclusive events. Those are events that cannot occur at the same time. A very simple example that I've written up here. If you have event A, which is to roll 3 on a die, so I say the event that we're looking for is, the experiment is we're going to roll a die. The outcomes, I have 6 separate outcomes. Well, the event that I'm looking for is that the simple outcome 3 shows up. So I roll a 3 on a die. Okay. Event B is that I roll a 4 on a die. So no complication there. Are these two events mutually exclusive events? And the answer is yes. Because if I roll a die, I cannot roll a 3 and a 4 at the same time. So again, this is a very simple... Hey, Abigail, I got you. Thanks. This is a very simple example, the roll 3, roll 4, at a very basic level of what mutually exclusive events are, especially in the context of what we're doing. All right, Abigail, I got you down for the points. Thank you for showing up tonight. I do appreciate it. So let's look down at the bottom. The reason I want to recap mutually exclusive events is because we're going to talk about the addition rule in terms of events and the probability of this happening or this happening. So the probability that events A or B will occur are as follows. So probability of A or B, it equals the probability of A plus the probability of B. Subtract out the overlap. Subtract out probability of A and B. Okay, if you have mutually exclusive events, and let me back out of this and see if my sketch is still up there. Yes, look at this beautiful sketch. I know that the rectangle in the background looks a little wonky. Let me see if I can do this. I think I can. I know it looks a little wonky, but this represents our sample space for 2 events, whatever they are. If my... I can go here, I got it overwritten. If I have an event here and an event here, and they're not in, and there's no overlap at all, these are mutually exclusive events. There's no overlap whatsoever. So if I take, let's see if it'll let me move it in real time. No, it doesn't like that, so let me back out. (2015) Mac. I love it, but okay. If you've got this situation, then these are not mutually exclusive events because there is some overlap right here in the middle. So when you're looking at, let me change colors real quick. When you're looking at the probability of A or B occurring, this being A, this being B, you could do them either way you wanted to. Then I'm looking at the probability of A, which was the area of that entire circle that represents event A, plus the probability of B, again, the area of the whole circle that represents B. Subtract out the probability of A Haha, I beat it. There we go. And it's a little bit under my big head there, but so you're looking at using the addition rule to find out what is the probability of event A occurring or event B occurring. Well, in this case where there's overlap, this overlap right here is referring to that. Because if you don't subtract it off, then you're taking it into account too much. And your probability is going to be not the number that you expect it to be. You've got to subtract that out. It's going to be too high. So you've got to subtract that off because you've already taken it into account. When you took the area of A into account, you took all of A, and you took all of B. So you've actually accounted for that area in the middle a couple of times. So you have to subtract that out. And I actually wrote it wrong. No surprise to my students in class, right? All right. This would be and. So if you skip through my videos to get to good stuff and you get to that before I correct it, shame on you. Watch the whole thing. So, okay, so there we are. There's my beautiful sketch from Geometer Sketchpad. And that is, these are two events that are not mutually exclusive. And what I showed before, they were mutually exclusive, where they cannot occur at the same time. All right, let me bring back up what I had before. I'm going to tell you this, for anybody that presents, Doceri is absolutely fantastic. And an issue with Doceri now is at some point I'm probably not going to be able to use it because I don't think the company exists and I don't think they support any updates to it. But it is absolutely fantastic. Okay, I said we were going to, not this, I said we were going to talk about the addition rule, and I want to go through a few examples with you. So let's take a look at an example now. A physics class has 40 students, okay? Let me highlight. 40 students, that's important. 12 are physics majors, 16 are females, and of the physics majors, 3 are females. So all of that is key information. Find the probability that a randomly selected student is female or a physics major. Okay, so I'm going to take out this at the bottom. And I'll rewrite it. So find the probability that a randomly selected student, you just reach in, randomly grab a student. What is the probability that it is a physics major or a female? Okay, well, how does this look? Where we are dealing with, and remember I told you that you're dealing with an OR situation. This is kind of an indicator in this type of especially simple problem in a basic stats class. So the probability that that the randomly selected student is a physics major or a female would look like this. Equals the probability, and I'll just put PM for physics major, plus, and I'm going to run out of room. Let me go down here. This happens a lot, doesn't it, with me? The probability that it's a physics major plus the probability that the randomly selected student is a female But you have to subtract out the fact that you have a physics major that might be a female. There were 3 of those, remember. So you have to take those into account so you don't double dip. So subtract out the probability that it is a physics, it can be a physics major and a female. No problem. I think I got enough room to put the numbers down below. The probability, and I'll do this all in terms of fractions, and then I'll break it down on the calc. And let me do this. I'm going to transition. I'm actually trying something. This is not going to be a hard transition. Let me go to my calculator page, and I certainly don't want to cover up everything, so I will use opacity. I'll bring the calculator almost all the way down so I don't forget that it's there. Okay, so the probability of a physics major, well, 12 are physics majors, so we've got 12 over 40, right? And by the way, if you're in chat, if you have any questions at any time, shout them out. Just send me a text or stop me. So far, so good, probably. Plus the probability of a female, well, there were 16 females, so 16 out of 40 would be your probability of reaching in and pulling out a female. And your probability of reaching in and pulling out a physics major is 12 out of 40. Well, in those 12 physics majors are 3 females. So there's a chance that we reach in and pull out a physics major and a female. There's a chance that we reach in and pull out a female that is a physics major. So you got to get rid of that overlap. If you remember that crudely drawn Venn diagram that I had on Sketchpad that I brought up a second ago, there's overlap here that we have to account for. So what is the probability that the randomly selected student is a physics major and a female? Well, if you remember, there were 3 of them, so that would be 3 out of 40. Okay. 12 plus 16 is 16, 26, 28. Minus 3, 27, 26, 25. So I get 25 over 40. And look at this. Just in case this fraction is so horrendous I can't do it in my head, I can go back to Ecamm. I'm not a sales rep for them, but I do like the program. And I can bring up my handy dandy. Turn it on. It seems to be working a little bit better tonight. Look, that looks a whole lot better. For whatever reason. I cannot tell you why. So now I'm just going to go 25 divided by 40. And I get, where's my, I get 0.625. Yeah, 0.625. Sorry, I got sidetracked. There's your answer. There it is. I need a button, just talking out loud, that I can lower. I can just hit the button real quick. Actually, I think I can. If I bring that all the way up. Time out. 1 second. Maybe not. I'll work on that offline. I'm sorry to waste your time sometimes digging into this, but I'm really am, believe it or not, trying to make this a bit more of a professional stream. And when I say professional, I don't mean the kind that you would pay for, but I just mean more professional in the sense of it makes sense. People come here and they actually gain something from it, instead of me just kind of talking out loud, blah, blah, blah. Okay, so there we go. Problem number 1. I see no questions in the chat. Still have only 2 students in the chat from class. We are at 7:21. People are missing out on 5 points, I'm telling you. And they're missing out on a great time on a Thursday night. Why wouldn't you want to be here? Just saying. Okay, so let's move on. As I was saying before, I'm trying to get ahead of the game and get my stuff up here first. And once I get it up here, then I'll have it for future streams, future classes. But I'm just not at that point yet. So I'm going to have to pull my notes up here and just write them out. So what I'm going to do, I'm not going to write out every single word. I'm going to talk through the details, and I'm going to write the important parts as I go. All right. Pull my notebook over. Okay, we had a problem last night that was actually kind of a double negative problem. I hate the way it was written. Kind of a pat problem. I have the antithesis, whatever, the opposite of it here. So we're going to talk about Cartan defects, and that's what I'll write up at the top right here. Cartan defects. And it's very similar to the one we did in class. So, of the cartons, like a milk carton, I suppose, produced by a company, 5% have a puncture. All right, awesome. 8% have a smashed corner. Smashed corner. And 0.4% have both. I'll put that so it doesn't run into my big head. There we go. So have both. Okay. So of the cartons produced by a company, 5% have a puncture, 8% have a smashed corner, and 0.4% have both a puncture and a smashed corner. They have both. Find the probability that a randomly selected carton has a puncture or a smashed corner. So right away, and one of the things from class, I'm giving you kind of some hints on the assessment anyway. You're going to have to determine what situation this is, and you can see it through the semantics of the wording of the problem. Find the probability that a randomly selected carton has a puncture or a smashed corner. So I'm just going to write that out. So find the probability that a randomly selected carton has a puncture. I'll put that first since I had it first up there. Or a smashed corner. So the probability that a randomly selected, what do we call this, carton, has a puncture or a smashed corner. All right. Equals. Well, I'm going to write it out, then underneath I'll put the probabilities and we'll finish it up. So I'm looking at the addition rule because I'm working with an or situation, right? So we're looking at the So we're looking at the probability of a puncture plus the probability of a smashed corner. Sorry, I have to go below, but subtract out the probability of a puncture and a smashed corner. Because in this particular situation, I'll draw it real quick down here. What we've got is an event that is a puncture. This represents puncture. And we have an event down here that represents a smashed corner, SC. And then in the middle there, whoops. No, it's not that now. See if it'll let me color in now. Here we go. That's the overlap. That's that piece of it. Okay. So I have to subtract that out because these are not mutually exclusive events. These occur at the same time. I'll do a couple of card ones in a second that are mutually exclusive events and kind of talk through those. Much easier, but neither of these are rocket science. What a great, well-drawn. Way to go, Mike. Okay, so let's go with the probability of a puncture. Well, we have that up here, don't we? Probability of a puncture is 5%, which you move that decimal 2 places and it's 0.05. Oops. 0.05 plus, and next up we've got smashed corner. What's the probability of a smashed corner? Well, that is right there, and that's 0.08. So 0.08. And subtract out the overlap from that Venn diagram. Remember, the Venn diagram is within the sample space of all the possible outcomes. You got compound events, simple events in there. I don't know that I've gone into too much detail about those particular vocabulary, but I probably should start talking about those now. But these are simple events inside of this particular sample space. Simple events meaning that there's just one thing that's happening. It's a puncture or it's a smashed corner. 0.05 plus 0.08, subtract out. So the last thing we're going to do is subtract out that probability that there's a puncture and a smashed corner. We have that number right here. I just moved the decimal out 2 places and it's 0.004. And then I go to my calculator and because I'm a professional, I go up here. I hope everybody knows I'm just joking around. And then I just take these numbers and I add them on here really quick, not too hard. So I go 0.05, so I got a nickel plus 8 pennies equals 13 cents. Subtract 0.004 and I get 0.126. So my answer for this is 0.126. Whoops. So I got about a 12.6% chance of getting a randomly selected carton that has a puncture. That has a puncture or a smashed corner. Sorry, sometimes I go back to context and I get lost for just a second when staring at it. So, okay, there it is. And let me know if anybody's still listening. You might be eating supper or doing something else. But if I've got the calculator kind of sitting in the background and you know it's there and can see it underneath, is that distracting? Honest opinion, it doesn't bother me if it is. If it is, I'll take it all the way out. If not, I'll just leave it kind of like that. I kind of like leaving it like that because it reminds me what page I'm on. But I'm okay either way. But if you see a reason for me to take it all the way down to completely invisible, just let me know. All right. I see nothing in the chat. I see nothing question-wise. I am streaming tonight, as I've been doing lately. I'm streaming from Ecamm on my Mac to YouTube, which is where I'm trying to do my primary streams. But I'm still going out to Twitch as well. So I still have these going out to Twitch in case anybody wants to interact from there. Last week I had somebody interact that wanted to sell me some art for my streaming to make it better. Wanted me to give them my Discord, share my Discord. And they'd be glad to send their portfolio to me. I don't know how much of that's real, but I'm just trying to be polite to them. It's fine. Okay, thank you. I thought so too as I'm looking at it, but I never know. Sometimes I've had folks on here, like in the background, you see I have those dynamic background, so to speak. I like that. I think it adds a little bit of something to here, along with my foreigny kind of music that I got going. I kind of like that. It's just in the background a little bit. Keeps it from being just my voice and boring. But I had somebody tell me one time, it was actually a previous student that said, you probably need to make that just a basic color. But I'll be honest with you, and I trust RD's opinion, but I kind of like that dynamic background. I'm not going to lie. Kind of like it like that. So that's just me. Let's do at least another problem. I'm going to do a couple of card problems, and I want to do one that is, I'm going to take this down for the time being. I want to do one now that has to do with cards. So let's talk about cards for a second, because as I've told you many times, the more years that I teach this class, the less and less people play cards as a hobby or with their family. I don't know why that is, but you just don't see it as much. Whoops. So real quick, typically you're dealing with 52 cards in a standard deck. There are 4 suits. Those suits are clubs, spades, diamonds, and hearts. Okay? There are 13 clubs, 13 spades, 13 diamonds, and no surprise, 13 hearts. So proportional across, and that makes up your 52 cards. Now, the cards that are here, and that's not showing up real good. Let me try again. Maybe this. The cards that are here are 2 through 10, Jack, Queen, King, and Ace. Not necessarily in that order. Oh my gosh. Let me redo that because my big head's in the way. Let me go down here. So you got 2 through 10, Jack, Queen, King, and Ace. I like the overlap, the way I got the screens, but I run into this where I put it underneath all the time. I got to get used to that. So there's the cards that you've got, and you've got these for every suit, right? So there are 4 2s, 4 10s, and so on. 4 4s. You get it. Okay. So that's what we're working with. So let's take a look at an example here from my notes. A card is selected at random from a standard deck of 52 playing cards. Find the probability of the following events. So we've got a shuffled deck. It's been shuffled at least 7 times. That'd be a good average amount of shuffles to shuffle it adequately. And they're placed out on the table, and you reach down and randomly select a card, right? So you're going to randomly select a card. So let's say, what is the probability? So you randomly select one card. I'll leave this up here. So you randomly select one card. What is the probability that you select a club or a 3? Okay. Notice one thing here. Ta-da. You've got an or situation, and we're talking about addition rules. So logically, I'm sure Mike's going to have this as his problem set. So the probability of your one card that you select being a club or a 3, it is as follows. The probability of drawing a club plus this addition rule plus the probability of drawing a 3, subtract out the probability of drawing a club and a 3. I changed up the and, but that little symbol represents and, the C represents club, and then there's a 3. So, okay, because I was running out of room. All right. So what's the probability of drawing a club? Well, how many clubs are in a deck of cards? We know this, right? There are 13 clubs out of 52. Okay. Plus, how many 3s in a deck of cards? 4. So 4 of the cards out of 52 are 3s. 13 of the cards out of 52 are clubs, so I've dealt with those situations. However, we have to determine whether there's overlap here, and there is, because there is a 3 of clubs. So because there's a 3 of clubs, we have to subtract that out. So the probability that it's a club and it's a 3, that only happens one time. So we've got 1 out of 52. Okay. 13 plus 4 is 17, subtract 1 is 16. I did it again, look at that. Equals 16 over 52. And then I, just like magic, I come over here. Look at that. Then I go 16 divided by 52 equals I can see it better up here actually. 0.3076. So I'm going to go 0.31. So about a 31% chance that when I draw one card, I draw a club or a 3. Okay. All right. Still, I haven't had any that didn't have this, right? I haven't had any that were mutually exclusive. So let's take a step back. Let me erase off everything that's here. And let me use the same situation, a standard deck of cards. We're going to draw one card. Okay. So what's the probability okay. What's the probability that we draw one card from a adequately shuffled standard deck of cards, and that one card is a 9 or a face card? Okay, no problem. I'm going to actually go underneath so I can write it all out a little bit more adequately. So I'm going to use the addition rule because you see there's an or here. So selecting one card. So the I keep doing that. I do that all the time. So we've got the probability of selecting a 9 plus the probability of selecting a face card. We have to define face card. And then we had subtract off any overlap, 9 and a face card. So what's the probability of reaching in and drawing a 9? We know that. How many 9s are in the deck? There's 4, one for each suit. So it's 4 out of 52. Plus, Probability of a face card. Well, we have to define face card now, don't we? A face card is a jack, queen, or king. So there's 3 face cards, jack, queen, king, and there's 4 suits. So there are 12 of those because I could have a jack of clubs, jack of spades, jack of hearts, jack of diamonds. King of all those, queen of all those. So I've got 3, 6, 9, 12. So that would be, there are 12 cards in the deck that are face cards out of 52. And then I'm going to subtract off the overlap. So what's the probability that I draw a 9 and a face card? Well, if a face card is a jack, queen, or king, that is not a 9. So a 9 and a face card are 2 different things. Drawing a 9 and a face card is impossible because they are mutually exclusive events. So in the scheme of this, you've got drawing a 9 here, and you've got drawing a face card here. There's no overlap there whatsoever if you want to look at it visually. So there's no overlap. All right. Sorry. Thought my music had gone. So what does that end up being? Well, it just becomes 0. So you subtract out 0. Because the probability of choosing a 9 and a face card is just 0. So what I really have here is 4 over 52 plus 12 over 52, which equals 16 over 52. I think we did this a little bit earlier. Let's go to the calculator. I'll bring it up like magic. And we've got, look at that. Is that what we did before? We did that before. Give me 1 second just to look at this if you don't mind. One second. Yeah, that's right. That's right. I'm looking at a previous problem, but we had what I'm going through in my head, we had the same answer for 2 of these problems. And for a split second, it confused me because I was like thinking that I had aligned it up wrong. So let's look at this problem. Then we're looking at 4 plus 12. Yeah, that's 16 over 52. Which is the exact same thing. I think I made it out to be 0.31 before, yeah. Sorry about that. I hope you see my logic there. I had done 2 completely different problems. I don't have the answers written out on my notes page. And in my head, I got turned around that I had glanced at it wrong or written something wrong. So I wanted to make sure that I corrected that if that was the case. But it's not. It just so happens that the 2 problems end up being giving me a 31% chance of occurring. All right. Hey, Victoria. Thanks for coming by. Just in time. I may have 1 or 2 left in me here. Excuse me, I've been going for just a little bit. Let me magically make this calculator go away. Isn't that amazing? Okay. Again, I'm trying to make this professional, not money-making professional or that kind of professional, but at least professional for a classroom setting online, for online office hours. So anyway, appreciate you 3 coming by. I've got all 3 of you written down. I'll put you in my grade book. And just a reminder, the +5 and any pluses that I get. I usually put an asterisk if I'm not putting points, so I just know you were there. And then I put +5 for the nights like tonight, where I'm putting some towards, say, a quiz category, like I am now. I'm sure everybody got 100 on the test. I haven't graded them yet, but we probably won't need any points towards the test category. But the quizzes, we had a couple, some off at the start when getting used to vocabulary in my class, so it'd be useful. Anyway, I leave those to the side, then I add them to the final grade at the end. So, All right. Let me move on to a different page. Again, I'm working through some problems with addition rule. The addition rule looks as follows. The probability of event A or B occurring is equal to the probability of A plus the probability of event B. Subtract out the probability of event A and B occurring at the same time or sequentially. Let's do at least one more here. I got one with a pie chart, but I don't want to draw a pie chart. Okay, let's finish this up. Unless there's any, I'll take questions or even questions on the test if you have some from last night. But let's finish this up with talking about a context of such a hard and difficult situation. We're going to roll die, okay? And this is where I'll close it up. So far I was working with cards. Before that I had a problem about smashed corner cans. There we are. If you ever see me, by the way, I know I watch streams all the time with people playing games. They're usually in with the game. I watch streams with people talking. If you ever see me pause for a split second, I'm usually looking at like what I was a second ago where I wasn't sure about that 0.31 because it seemed to come out the same for two problems. And then I also have my iPad, so I have texts on, so text will come up. So for a split second in time, I get turned around because the text comes up and I just glance at the gist of it before I swipe it away. So I'm not really crazy and I'm not just kind of losing myself there. I really do get sidetracked for a shiny object when that text comes in. All right, we're going to roll a die. Find the probability of each event. So what is the probability of, rolling a 5 or a number greater than 3? So notice how I wrote that. What's the probability of rolling a 5 or a number greater than 3? I guess I'll put number in there. So a 5 or a number greater than 3. Okay, let's take a look. I don't know. So we know this is an OR situation. We know we're rolling a die. We've got a single event here. So I've got the probability of rolling a 5 plus the probability of rolling a number greater than 3. Subtract out the overlap. Can I roll a 5 and a number greater than 3? Okay. All right, let's take a look. The probability of rolling a 5. Well, we'll deal with fractions and we'll convert them. 1 out of 6. The probability of rolling a number greater than, that's a 3. Yeah, greater than 3. Well, greater than 3 would be 4, 5, and 6. So we have 3 out of 6, right? Not 3 inclusive. That would be this. We don't have that, so it's just greater than 3. So that would be 4, 5, and 6. Okay. And then subtract out the overlap. Is there a number the probability of rolling a 5 and a number greater than 3? Well, 5 is a number greater than 3. I had to think for a second how I was going to explain it. A 5 is a number greater than 3. Therefore, the overlap would be 1 out of 6. Okay. And I have 1 plus 3 is 4 minus 1. Ooh, it's a toughie. Tough. There you go, 0.5. It's a half. Okay. What an astoundingly tough rocket science problem that was. But in all honesty, I hope that this kind of brings what I was talking about to a close. I've been on here for about 40 minutes. I've got 3 students in from class, got some other folks in. I have worked through some problems here. Let me just backtrack a little bit. I talked about mutually exclusive events again, just to kind of recap what we talked about in class. Then I talked about the addition rule. Again, we talked about this in class as well, but I said I will elaborate a little bit and work through some problems tonight and take any questions you might have. Talked about a physics class, females, physics majors. If you randomly selected one, what's the probability that it would be a physics major? probably be a female, or probably it would be a female that is a physics major. We had all the data from the problem. I didn't write the whole problem, I wrote the information from it. And then carton defects, what a great problem. You're on the assembly line, 5% have a puncture, 8% have a smashed corner, blah, blah, blah. We worked through that one and got 0.126. Then we went to 52 cards. The scribble at the side was I just kind of at the end. But we have 52 cards, we have 4 suits, 13 cards in each suit, and what are the cards? And I just kind of went through that again just as a reminder. Randomly select one card. We went through a couple of problems here. So I went through several problems tonight with this, and I think I'll just kind of sum it up there. Nothing major, just a little bit of an extension on the addition rule, and certainly a chance for the class to earn 5 points back towards the quiz category. And I always appreciate folks being here. So probably what I need to do, and again, I show this just about every time. I'm so proud of my little screens. I go to this screen, which is my interview screen. Isn't that great? So that's a black background, but I could write over the top of that as well. I've got it kind of perspective off just to be kind of cool. But I could bring you in as guest 1 and guest 2, and I could add more guests in that probably on the other side, 3 and 4 if I had to. I probably should do that. Probably should have 2 of these screens in case more folks come in. And we could have a real good knockdown, drag out discussion about some of these topics and really get to the root of some issues if you have any questions. So far with the addition rule, I truthfully believe probability is something that we all kind of intuitively know. Sometimes we know it the wrong way. We apply the wrong numbers at the wrong times. And so this section typically brings it home a little bit for you. So you start seeing things a little bit more in context of the numbers. Not rocket science problems, but the layout of these apply to a lot of the things that we see in the real world. So I think I'm going to stop it there. I got Artemisia, Victoria, Abigail all stopped by. Appreciate you guys stopping by. I've got your names written down. If there's anybody else lurking in the background, either on YouTube or on Twitch, YouTube should be my students. That's typically where I go from class. Just send me a little shout out. Let me know who you are so I know that you were in here during this time. And that's 5 points to you. And I think that's where I'll close on this Thursday. If you get a chance, I've got calculator videos out there. We're not really into that yet, but I'm trying to add more each week. But when we get into a little bit more of the calculator situation where it is a much needed endeavor, then we'll put some stuff out there. Sure thing, Artemisia. I appreciate you guys being here. I do. I'm kind of a nerd. I don't mind doing this, kind of a hobby of mine, and I enjoy trying to help folks in class become better statisticians, even at a basic level, so that hopefully sometime in my life I'll see one of my students going to be a math major and come back around and maybe teach at the college with me. So anyway, maybe that's a long shot. I don't know. So, all right, you guys have a good rest of your week. If you have any questions, send me an email, and I will be updating the Moodle soon to include the grades that I handed back last night. I'll update those in the grade book. So, sure, Abigail. I'll see you guys later. Ladies, appreciate you stopping by. Anybody else that came by lurking, appreciate you. Thanks, and I will see you next time. Oops.